Well, hello everybody. Good morning, afternoon slash evening, depending on your time zone. So my name is Aaron Standard, and I'm joined here with my colleague Gregorius Sodharmo.
Good
Um,
morning.
Good morning. Well, we have a lot of stuff to cover as far as recent developments on Akka.net and also some of the other new initiatives and projects we're working on currently. So why don't we just go ahead and dive straight into that? We'll go ahead and start with our recent Akka.net releases here. And let me go ahead and kind of just rejigger the screen a tad. All right. Recent Akka.net releases. So, thanks to some platform disruptions from Azure. Oh, you know what I forgot to do? I forgot to go ahead and upscale the resolution on this live stream. Apparently, what's it called? StreamYard basically does it not even necessarily in 1080p by default. I completely forgot to set that. So, my apologies to everyone watching. Got some feedback on that at our last meetup and forgot to incorporate it in this one. Whoops. We'll have to get that right for June. But anyway, where I was going with this was we had to make some pretty major changes to our build systems, unfortunately, at the beginning of April. Well, really, kind of at the beginning of May, end of April. We've used Fake, specifically Fake 4, for nearly 10 years on the Akka.net project. I think we migrated to it in 2014 sometime. So maybe even 2015, but for a long time. I wrote Akka.net's original build system in Albacore. If any of you remember that project, that was a Ruby a Ruby make system for .NET projects specifically. And this was, all the rage back in like 2013, 14, somewhere around there. One of our F# contributors a long time ago migrated us onto Fake. I've maintained that system and even replicated it to many other projects over the course of 10 years. But the problem that we ran into is that Fake basically had two new major versions ship since Fake 4, Fake 5, and Fake 6. And migrating from Fake 4 to either one of those was about as much trouble as just moving off of Fake completely. And that's because basically those versions are completely different from each other. So I figured, you know what? I've kind of embraced build system minimalism in a lot of our own projects here at Petabridge. We used a Nuke build for a couple of other projects as well. We've kind of migrated off of that in those areas. So we're just going to stick with basically the vanilla .NET tooling system now. And we'll also talk a little bit about Incrementalist, which is the one piece we have to use to augment our build system. We migrated off of Fake completely. And the reason why this was necessary was because the new updates that Azure released to all their build agents yanked mono support off of all those build agents. And then on top of that, they also deprecated some versions of .NET Framework as well, which had the added benefit of breaking our code signing server, which is yet another thing I had to replace at the beginning of May. Good times. So that was a big epic. Both Gregorius and I pitched in on this. We've migrated everything over to using a vanilla .NET build system. Now, the one component that we needed to reinstate and replace was Incrementalist. And I wrote a blog post that went live. I guess this would have been just after our last community stand-up, all about what Incrementalist is right here. Incrementalist has been a part of the Akka.net build system since 2019. So it's been around for quite a while. And it's available on the, let's see, I think I have a link here to the GitHub repository. Let's see. Well, I have a link to the NuGet package, and that should link to the repository. Let me pull that up. Basically, this is available. It's an open source project. It's all licensed under Apache 2. And I think we include a link to the agenda in the description here, so you can get all these links out of it as well. But the basic idea behind Incrementalist is that we completely rewrote it this year. This is a project that I actually used AI really heavily to help me kind of restructure, because it's a small enough library where I felt like AI could get a pretty good handle on the context with it. So I used Claude Sonnet 3.5 and 3.7 and a little bit of Gemini to go ahead and basically repurpose Incrementalist and just being a library that spat out a CSV file of the build graph you needed to run. And we would use Fake to parse that and then run it. Instead, it's now a standalone .NET tool that will actually run all the build instructions for you. So we restructured our build pipeline in Akka.net to just basically install Incrementalist as a local tool. We have some, if I go to the Akka.net project here, let me pull that up. If I go to the Akka.NET project and we take a look at this little .incrementalist folder, we have a couple of configuration files. So like I have a multi-node only or test only configuration. This uses a little bit of globbing to basically say, we do not want to run these tests. We do want to run these tests. And that'll allow us to perform some of the filtering that Fake used to do. Akka.NET's end-to-end build time, if we let everything run continuously in a single process, would probably take 2 to 3 hours. So instead, we try to run bits of it in parallel. And this is similar to what other big projects like ASP.NET Core do as well. So Incrementalist is designed to really kind of help keep this simple. And the primary thing that it does is it leverages your Git diff to figure out, based off the changes you've made, what's the minimum number of projects that we need to run in order to fully cover that set of changes. So it uses the MS Build Graph API, and it also uses a libgit2 to basically figure out what's the minimum number of projects that all need to run. Anyway, it's available as an open source package. We just recently, by recently, I mean, I think we did this on Monday, shipped a 1.1.0 beta of it that includes a couple of new pieces of functionality. One is you can now run processes that are not just the .NET compilation toolchain. If, for instance, you wanted to run some sort of, asset minifier for building a bunch of ASP.NET Core applications, you can now do that using the run process verb. And then on top of that, and by the way, these were all external contributors who wrote all this stuff. So really cool. They all kind of picked up our blog post and YouTube video on Reddit and ran with it. The other thing that another contributor did was migrate from using the full Roslyn solution analysis to just using the static graph engine. This cut the amount of time it took to analyze Akka.NET from like 45 seconds down to under 5 instead. So it's a order of magnitude improvement for analyzing even a fairly big solution like Akka.NET that has nearly 100 projects. So I strongly recommend that you give that a look if you're running big projects or if you have a mono repo or something like that. Incrementalist will be pretty useful, I think. Now, aside from just working on our build system, we actually did manage to ship some major changes to Akka.NET itself, beginning with adding XUnit 3 support to the test kit, which was a pretty popularly requested item in our Discord.
Mm-hmm.
So, Gregorius, why don't you take it from here?
Yeah, so we added support for XUnit 3. To use it, you need to use the akka.testkit.xunit package. The akka.testkit.xunit2 still supports XUnit 2. We're dropping support for the original XUnit. The consequence of this is that this is a limitation of XUnit 3. If you want to use this, then you have to target either .NET Framework 4.7.2 or .NET 6. That's the minimum.
This is .NET 8 on here.
.NET 8, sorry.
Yeah, no worries. Yeah, so, right now, Akka.NET still internally uses XUnit 2 everywhere. We'll probably migrate to XUnit 3 for our own purposes at some point in the future. Probably not until after Akka.NET 1.6. Let's see. You did that. You also shipped a new version of Akka Analyzers and incorporated this into Akka.NET as well. So take us through these two. Let's see. What's this right here? What is the Akka 1008 rule? Should not use system to create child actors. Okay, this was for mostly fixing a problem we had inside Akka.NET itself, if I recall correctly.
Mm-hmm.
Yeah.
Yep. This is one of the problem where we mistook actor creation, and instead of making it a child of the actor, we actually created as a root actor, which is a big no-no. So we had a bunch of leaks, I forgot what project it is, but
it was the Akka persistence recovery permitter was where we saw that show.
Oh yeah.
Yeah.
Right.
So
yeah.
One of our customers sent us a Phobos chart showing that there was like 100,000 of them running around. And it's because that actor was restarting constantly. So yeah, this was a bit of a boo-boo. By the way, I think this code action is this misnamed on here? I think it might. Well, we'll take a look at that. Looks like that got copied and pasted from something else potentially.
It could
Um,
be.
yep. So we did that, and then the other big fix was basically this caching the materializer when we're working with Akka streams.
Hmm. It's not performant. Uh, Calling context that the materializer is not performant because it actually creates new actor materializer every time you do it. It's a lot more performant if you just, cache a single instance of it and reuse it in your stream. If you like, you have a bunch of stream being stored inside a single actor or in a single piece of code, basically.
Yeah. Yeah, definitely. I've seen this show up in the wild before where someone was like looping through a list of collections and creating a new materializer each time. And they asked, why do I have 40,000 actors? It's like, well, this is why. So yeah, we added an analyzer rule for being able to tell people to cache those. And then we're not done with all the stuff you did on 1.41 yet. This was a
Mhm.
super annoying from a developer experience standpoint. This was a really bad design choice originally. Um,
Mhm.
not well, basically,
Well,
yeah, give us some background on that one.
it was made with the best intention, but sometimes, the best intention doesn't really fly. The way group by works is that it caches old completed streams inside of it. So the original developer thinks that it should be limited just to make sure that we don't run into a memory leak problem. So now, if you're using the old API, you can put in a negative number on the max number of substreams. Or if you want to use the new API, just drop that argument altogether. Then it will allow group by to create basically infinite substreams. But if you have a really long running stream with unbounded uh, group by uh, specifier predicate, don't do this because it will guarantee that it will create a memory leak.
Well, it's just that you might have groups that aren't active after a long period of time, right?
Yeah.
Um,
The only problem is that the reference of it is still being held inside the group by stage.
we could probably fix that and and like garbage collect them periodically.
Could
Um,
be. Yeah.
base Basically, we have two different stages that look real similar. There's partition, which allows you to chop up a big stream into n number of substreams, and you can go ahead and specify a partitioning function that'll figure out which input goes where. And that makes sense to have a specific number of partitions for that design. That same idea got copied over to group by, and it was not that is not a good decision. The reason being is that group by is supposed to basically create a group per key. It's not trying to it's not trying essentially in this case the number of groups has to be dynamic in order for that API to make any kind of intuitive sense. And whereas with partitioning, it doesn't. So it's like grouping by is basically about key uniqueness. Partitioning is about parallelism. So the way group by worked before is you had to specify the maximum number of groups. Well,
Hmm.
if you have no way of knowing that before you start processing a data stream, that makes this extremely awkward to work with. You would essentially have to pre-calculate the number of theoretically max streams you might have. And if you passed in a huge value like int32.max, well, guess what? You've defeated the purpose of having that API in the first place. So this was just a case of bad sort of developer experience that needed to be cleaned up a bit. And Gregorius, we should probably file an issue about garbage collecting and then recreating idle group streams at some point in the future. That
Hmm.
may not probably don't need to do that immediately, but we should probably at least have that documented somewhere in case someone runs into it.
Hmm.
Oh, and then this sucker, the source of most of the racy unit tests inside the Akka.NET test suite has finally been dealt with. Now, this says this came from me. This was primarily Gregorius's engineering work. I just made some performance fixes to it, basically, is all that I did. So, yeah. Um, Let me go ahead and go back to, I guess, the original issue here. This is all about substreams and all the problems people were having with things like the broadcast hub, for instance.
Mhm. Yeah, we found out that there was some fixes that's already implemented in the JVM side that we haven't actually implemented in our side. Um,
Old fixes too.
yeah, it's old fixes from like 2016 ish, and basically, if you have a sync that is canceled, it can actually stall the broadcast hub forever, which is really bad.
Yep. And this caused other problems with a bunch of other stages that all use substreams. So it's basically the common through line here that
Mhm.
substreams could basically like disappear into the void, more or less, depending on when things shut down and when things canceled inside of there. So we noticed this big time. I think it was when we were working on AquaStream's Kafka in March. I think is when this came up. We noticed that the benchmarks around using the partition streams would hang after processing a very small number of messages. Um,
Mhm.
and it was because of this problem, basically, was creating that.
Yeah.
Um,
And kudos to the original JVM developer. This is a really, really hard problem to solve because
yeah,
it's really nasty.
yeah, definitely. That was not remotely intuitive at all. But these were like some of the worst offenders in our test suite, and there might still be some cases where they might be racy as a result of just timing constraints. But there was like a fundamental structural problem that created this issue here. So I think that covers it for everything that we've shipped over the past month or so. We have an absolute ton of work coming down the pipeline on Akka.net right now that's happening. So let's go ahead and walk through some of that. The first thing I want to talk a bit about is our upcoming webinar that we're doing on May 22nd. So that'd be, I guess, 8 days from now. So next Thursday. There's a registration link in the description of this YouTube video if you want to go and check that out. We'll probably make the video available on our YouTube channel at some point in the future. But if you want to go ahead and get the recording right away, make sure you go ahead and register. Basically, we're going to talk a lot about doing modeling Akadana applications, like actually how to model a domain, how to design messaging protocols, how to basically design your actor hierarchy so stuff can get distributed eventually, even if you build locally first. All really good ideas. The webinar is going to last for an hour, and I'm going to do a 15-minute question and answer period afterwards. So definitely go ahead and check that out. Next thing I should mention is that we just published this on the YouTube channel this morning. We have a video out on Akka management. This was very timely, actually. I had an Akka.cluster training last week where a lot of questions came up around how exactly Akka management works. And we do cover some of that during the training. But I figured doing a 25-minute deep dive on Akka management and Akka discovery would probably merit its own video. And right after I prepared the content for this, like last week, over the weekend, one of our customers experienced the exact type of outage Akka management is there to prevent, basically, which is that seed nodes are susceptible to problems where large ranges of static addresses become unavailable all at once. In this customer's case, they had their Kubernetes clusters spread out between two different Azure, I don't know what you call them, availability zones. Basically, these are like separate data centers inside the same region in Azure. And the long story short, Azure had a problem where two of these were not able to contact each other. Basically, the link between the two data centers got disrupted in a very sharp and pronounced way, where essentially it was like 0 packets made it through for about 5 minutes. That completely nuked their Kubernetes cluster and the applications that were running inside of it. And as a result of the fact that they were using static seed nodes in Akka.cluster, that system had trouble coming online and had to be restarted again afterwards. Akka management can kind of help basically alleviate that type of problem by making the process of sourcing your seed nodes dynamic and driven by the environment. And on top of that, if the even if your Kubernetes cluster was potentially having some problems here, an Akka discovery tool, like even the Kubernetes discovery tool, would be able to know, hey, we know that there's other pods that are running in a machine we can't reach right now. Unless, how do I put this? if there was a problem that severe in the Kubernetes cluster, a lot of other stuff would break. If like their etcd system they use for synchronizing control plane state was down, you'd have even more severe problems than what Akka.net could address. But the basic gist of it is that Akka.net would be able to use that information to safely reform a cluster afterwards, and they wouldn't have needed to restart their system. So check that video out. It's on the channel right now. And I'm also working on a blog post for that, which should be live later this afternoon. I'm about halfway done with it right now. And then we have all of the big Akka.net changes that we're working on. Boy.
Mhm.
All right, Gregorius, I'm going to have you take us through the Akka.net persistence stuff you're working on. And there's even one more Akka.net persistence issue that I haven't addressed yet, which is that delete issue you're working on with Akka.net persistence SQL.
Mhm.
So I guess why don't we start with Arjun's issue here that he contributed?
Yeah, this is an improvement, a feature that Argent added to uh, journal and snapshot initialization, in that you were able to specify the supervision strategy for both the journal and the snapshot. So now you can actually, tell Akka persistence what it should do. It should those fails, basically.
Yep. So by default, it uses the default supervision strategy, but if you need something custom, so I think Arjun's issue came down to the fact that SQL Server basically had a DNS level problem, and the journal went berserk trying to constantly restart it while that DNS resolution wasn't working. This will let you configure how do you want to handle a journal or snapshot store initialization failure. And it uses just an Akka.net supervision strategy to do all this stuff. So this is a good improvement. The other improvement we've been making around resiliency, and this
Mhm.
unfortunately is a breaking change. We're going to have to roll out updates to every single Akka.net persistence plugin for this, but I think it's a fairly necessary breaking change, though.
Yeah.
Gregorius, this was your baby. Why don't you take us through
Mhm.
it?
So internally, a circuit breaker has a built-in feature that it could time out the delegate, the async delegate that it's handling. The problem is that when we switch over to async, I don't know when that was, but we didn't take cancellation token into consideration. So the cancellation tokens being used by the circuit breaker wasn't actually being passed down into the protected async delegate. So what happened is that the async delegate runs as a detached task.
Yep.
So when as the circuit breaker timeout happens, well, the circuit breaker stops, but the underlying delegate still kept on running. So we have to unfortunately introduce a breaking change in the delegate fingerprint itself, the method fingerprint. So this is a breaking change, but it's for the good, I think.
Yeah, the long and the short of it is that, as Gregoria said, the cancellation token comes from the circuit breaker, but that cancellation token never actually got passed into the persistence plugin. So we
Hmm.
had a customer, one of our production support customers, tell us, "Hey, I'm seeing these circuit breaker failures when I'm trying to." Was he trying to insert stuff or delete it? I
Yeah,
can't remember. Um,
insert.
he was trying to
It's
insert
a
stuff.
yeah.
Yeah, in a pretty busy system, goes, "Hey, I'm seeing these circuit breaker timeouts when I'm inserting stuff, and that's resulting in my persistent actors killing themselves and reporting that the persistence operation failed. But I see that data show up in the database, not long afterwards, and that's because of basically this sort of issue here, where as Gregorius said, the actual database operation is still running even after the circuit breaker times it out. Um, Now, the bad news with this is that Gregorius, you did a proof of concept already on this feature with the
Mhm.
Akka persistent SQL. And we discovered that the low level is it Microsoft.sql.common or what's the name of the library? SQL.data.common.
It's
Is that it?
system.data.common.
Yeah, and this is like the ADO.NET low level API that gets shared between all the different database drivers. So MBG SQL uses it, a SQL client uses it, etc. So this is kind of what implements. I think this is where the T SQL standard gets implemented is down there.
Mhm. It's basically part of the .NET Standard 2.0
Yeah.
spec.
And you discovered that so you actually stepped through all the layers of all the database driver code in .NET.
Hmm.
And the actual low-level database transactions in SQL.data.common do not accept cancellation tokens and are not really asynchronous either. It's all kind of faked, basically.
Yep.
It's
That was the problem. See, the funny thing is that other maintainers for MySQL and PostgreSQL, they actually implemented the correct way. They implemented the code the correct way, but Microsoft that data that SQL client hasn't actually updated their code since 2019, so they're behind.
Yeah, here we go. Let's take a look at this little trip down memory lane for everybody. Yep. Implement async transaction begin commit rollback methods from 2019. I think this guy, yeah, he's the lead developer on MPG SQL, so the Postgres provider.
Mhm.
So he got that implemented on MPG SQL, but SQL client, on the other hand, has not gotten the love just yet. So
Yeah.
that is very unfortunate. If anyone with any pull at Microsoft has the desire to go ahead and push this downfield, that'd be great. But otherwise, we're going to. So I guess the long story short is all this work we did to try to basically stop this problem from happening on SQL is kind of for naught, unfortunately, with SQL Server. That being said, when they do add support for it, it should be very easy for us or LinkedIn, the layer underneath us, to be able to do that. But it will work properly for Postgres, MySQL, and probably SQLite. Maybe we'll have to double check that.
Mhm.
But it probably should work for all of those. And it'll definitely work for the other third-party databases we support, like MongoDB, Redis, and Azure. We'll go ahead and basically make sure that cancellation token gets propagated for all those. So that's kind of a
Mhm.
big project we're going to have when Akka.NET 1.42 ships. Okay. Next, we are going to take a look at, fun. This is my big project that's going on right now. Redesigning Akka.io.tcp. Let's pull this up here. So I've already done a couple of other pull requests related to this. Let me get into a little bit of the backstory on this project. So Akka.io is our general purpose TCP/UDP interface for communicating with actors. Akka.remote does not rely on this. It uses .NET, which is a different sort of abstraction for being able to work with sockets. But Akka.io could, in theory, be something that powers Akka.remote in the future. Well, Akka.io has some problems. Namely, if I go take a look here, one of the big problems I identified with it. So we have a customer that's doing something in the meter data management space. So running large numbers of power meters, water meters, that sort of thing. And they're trying to support hundreds of thousands of concurrent connections that come in all at once when the meters try to transmit a reading, right? And they noticed that there was a fairly large number of connections that simply weren't accepted or handled properly. I already made some fixes for that in Akka.NET 1.541, I think, or was that 1.542 where we did that? I don't remember. It's in the latest nightlies or whatever. But that didn't quite go far enough to resolve the issue. The fundamental issue is that the TCP connection is a miraculous combination of being over engineered and under engineered at the exact same time. So it had all this complex Byzantine code for managing byte buffers, but still managed to basically corrupt them and not transmit them correctly. It's one issue we've noticed. The other, the other issue is that it doesn't really handle socket events correctly, in particular, dealing with closures. One really obvious example of this is that when we would go ahead and send a poison pill or whatever to, let's say, an inbound TCP connection actor, the socket actor would never report back to the handler that it had closed at all. Therefore, the number of closure events that we received was pretty minuscule. We'd only actually get them whenever the remote socket closed correctly, that's pretty unacceptable. So we've made this much more robust. Our error handling code is a lot better than it used to be now. In fact, one of the things that's kind of funny, if I go back to taking a look at this pull request, and if we look at the build server failures, let me pull this up real quick. All right, so some of the build server failures that we have here. So we have all these specifications around how to deal with like socket closures. The thing that is hilarious is that we had written all these tests to expect like error closed whenever a socket like closes normally, more or less. Well, I re-architected it so we try do our level best when we close a TCP actor to gracefully terminate the socket connection. So rather than like treating this like a failed error case, which it absolutely shouldn't be and isn't in real life, now we get a pure close message back, which is correct. That's the correct way to close a socket. But all of our tests are built against this bad assumption we had from before. So this is going through a pretty major overhaul right now. The other benefit of this overhaul is I've deleted at least half. Well, not at least half. I also added some code back, but we've deleted about 50% of the Akka io.tcp code, and I've got a lot more I can delete for the record. And we've improved the performance. We went from like, this is sort of probably the most base level performance right here, which is how quickly can we service a single socket. The number of clients that go up, the message count is fixed, but the number of clients serving it goes up, which is why you see the number of requests per second increase. We were able to get from about 18,900 sort of requests per second up to 22,200 requests per second, which is about an 18 to 19% improvement. And that's, by the way, with just like honestly getting rid of a bunch of garbage is all that we did. We haven't even done anything super creative yet. Like an example I thought of on my drive to work this morning, we could do what Akka.remote does, which is have reading and writing happen on separate actors, which would basically allow us to really work in a much more duplex fashion. That'll probably pump up the throughput even more. It'll make the code more complicated, but it will make it tremendously faster because input and output won't be passing through the same mailbox anymore. But like even without doing anything architectural like that, just like deleting stuff that doesn't need to be there, it's going a lot faster. Now, we're not quite done with these changes yet. There's a number of other important fixes that need to happen with Akka IO. Akka IO has never properly supported setting system buffer sizes, which is useless. You absolutely must do that. If you're trying to use TCP for anything other than sending really tiny messages, you need to be able to specify your system buffer size. This is going to determine how many messages you can have pending before you do a read inside your system. The lower that value is, and it defaults to a pretty low value, 8 kilobits, I think, is the default for the send and receive buffers. It's going to severely limit how quickly the system can work. So we're going to go ahead and add a real configuration setting for that. We're also refactoring the state machine to not support all of the read and writing pausing that we had before. I think that was originally built there to support back pressure inside akkastreams.io. We might add that back. I'm not totally sure, but back pressuring by simply not reading messages from a socket seems super ill-advised. That's going to result in data loss. That'd be like trying to back pressure incoming HTTP requests by sending them server too busy messages, which there's better strategies for doing that. Buffering would be a good example. So I think we're probably not gonna. I think we're probably going to keep things simple and then try to get the throughput high. Most importantly, though, we need to make sure the system is fully reliable. So that's what we're working on right now. All right. And then finally, in terms of other components that are getting a major reliability upgrade, let's talk about DistributedPubSub. Let's see, Gregorius, where do you want me to begin here? Do you want to do wait for subscribers, or do you want to do some of the character parsing stuff? Oh, Gregorius, you there? Says you're muted.
Sorry. Yeah, sorry about that.
Yeah.
The wait for subscribers is a good place to start, is Eddie.
Go ahead.
Okay, so this is a new feature that we're planning on adding for 1.5.42, in that we would allow user to tell PubSub to just wait until a subscriber subscribes to a topic and buffer everything if there's none there's actually listening for now, instead of just bailing out. A lot of people are having problem coordinating between 2 points in a PubSub system because of this.
Yeah, we've got multiple customers that have kind of run into trouble with this, and solving it by hand today requires basically like having the publisher wait for acknowledgments from at least one subscriber that they got the message, which kind of defeats the purpose of disintermediating stuff. So we're going to go ahead and add this wait for subscribers feature. We're not going to add things like here's the number of subscribers and blah, blah, blah. Nope. It's a Boolean value with the timeout. That's basically what it's going to be.
Mm-hmm.
The idea behind this is that there's a lot of scenarios where the subscriber and the publisher start up roughly at the same time, but on two different nodes. And there's replication lag built in DistributedPubSub. Now, dialing up the rate at which DistributedPubSub circulates its gossip isn't an awesome solution either, because that would basically result in a lot more traffic for potentially fairly minimal gain, and it still would not help these really close proximity timing issues very well. So a better solution for this is adding a time buffer on the publisher side, which is, look, wait for up to 10 seconds for a subscriber to show up. And if a subscriber does, we'll go ahead and publish it. And then we can also add some other like security parameters to this. Like when I say security, I don't mean SSL. I mean like, here's the maximum number of buffered messages per topic that can be buffered at any given time. If we get more than that, start telling the publisher to slow down or start dropping messages, which is, a thing we had to do inside a system like Akka.net. You can't let someone just, I don't know, go completely out of memory, doing something that they probably shouldn't. So that's a set of design choices that we're in the process of reasoning about right now. I'm hoping to get this out. I've already told a customer that would have a version of this up by the end of the week. So I guess we better get cracking on this.
Mm-hmm.
So anyway, we're hoping to get this done as part of Akka.net 1.42. A couple of other things that I guess that are in the hopper right now. So the Akka.io TCP stuff's a big one. I think we're probably also going to be doing a round of updates on all the persistence plugins once this goes out. And then the metrics that we added to Akka.io. So we added some metrics for being able to get data from a TCP listener. Number of accepted connections, number of retried connections, all that good stuff. That is going to kind of form the basis of the metrics we're trying to add to Akka.remote, and that'll all get incorporated into Phobos in a new release in the future. So we've got a lot of different little irons in the fire here, and we're working pretty furiously on trying to make sure that all of your bug reports and issues get addressed. So I just want to go ahead and thank you all for submitting those. It's kind of helped making the Akka.net project get better and better all the time. And I guess thank you for joining us this week. Gregorius, I don't really have anything else to add. Do you?
No, not really.
All right. Well, in that case, we will go ahead and catch you all in June. Thanks for attending. And don't forget to like and subscribe. And check out our Akka management video while you're at it. Thank you very much.